Hey guys, how are you all? My name is Harshit Devedi friends and I welcome you back to my video. So in this video friends, I am going to talk to you regarding the homeostasis in ecosystem. Now, first of all friends, I would like to tell you that this video is in English. If you want to watch the Hindi version of the video, the link of that is given in the description box below. I've also made the Hindi version of this video. So I will in detail tell you what is this homeostasis friends. Actually, this homeostasis deals with maintenance of body temperatures. Okay friends, this is what is homeostasis and this has been done through a whole variety of things. For example, there is a procedure named as regulate, then there is a procedure named as conform, then there is a procedure named as migrate, and then there is a procedure named as suspend. And in the end, I'm going to talk to you about the how homeostasis is performed in an ecosystem as a whole. All of these things, regulate, conform, migrate, suspend, is going on in an ecosystem only friends. But yes, regulate, migrate, suspend, conform, all of these are happening in particular species. So these things will be detailed by me friends. So starting, my name is Harshit Dwivedi. If you want to follow me, the link of my Instagram profile is given in the description box below. Also, this video is in English friends. If you want to watch the Hindi version, the link is given in the description box below. So basically, homeostasis deals with the maintenance of a stable equilibrium. Stable equilibrium is the biggest thing which is happening through it. So what is happening that the bodily part functions, actually what happens friends, see, the point is that for example, if you talk about humans, first of all, we should start with humans. In humans, humans are having some internal environment. Now, the internal environment of human beings is conducive for all the bodily functions that are going on. And this internal environment needs to be sustained, irrespective of the fact that what is going on outside. For example, if I, as a human being, I am in, say, Sahara Desert. Now, in the Sahara Desert, it is too hot. The temperatures are around 52 degrees Celsius. Okay. Then the very next day I'm going to a continent named as Antarctica. Now in Antarctica, the temperatures are minus 50 degrees Celsius. So from a transition to this 52 degrees centigrade in Sahara to minus 50 degrees centigrade in Antarctica, there is a big change in temperature. A huge change in temperature is happening, friends. But for me to live, the internal systems which are going on inside my body, they should be constant. And this is what is maintained by this process named as homeostasis. Homeostasis does that whatever is going on inside me, that will be maintained constant. So constancy of the internal environment, this is what is, you can say, targeted by the organism to survive despite what is the external environment at that point of time. Now, this is done through many processes. This is done through physiological processes. Because physiological process, for example, one example of physiological process is sweating. Pasina nikalna, sweating. So what happens in sweating, friends? See, whenever you sweat, you will see that in summers, when a lot of summer is going on, heat is there. So you will see that your body will start releasing fluid. You will sweat profusely. Now, when you will be sweating, friends, what will happen? At that point, some things will happen. The very first thing that will happen at that point of time when you are sweating is that your body will become a bit wet. So when your body will become wet, you will feel that yes, your body is having a cooling effect because that liquid is going to make your skin cool. Then obviously when that sweat will be evaporated, it is going to take away some amount of heat from your body. So that will make you feel cool. So both of these processes are happening and through this sweating, you are feeling nice. But this sweating has its own advantages and disadvantages. For example, when there is a lot of humidity, okay friends, when the humidity is very high, in that cases the sweating will not be very effective. For example, if we talk about coastal regions, friends, for example, if I talk going to talk about Mumbai, or if I'm going to talk about Gujarat, in Gujarat there is a Dwarkadhish temple, so the coast of Gujarat. So what is happening there, friends? Here the humidity is very high in coastal areas. Now, what is basically humidity? Humidity means the amount of water vapor present in the air. Okay, and there is a level till which the air can hold water vapor. Now, if we talk about, say, Uttar Pradesh, okay, if I am talking about Uttar Pradesh, now what is happening in Uttar Pradesh, friends? In Uttar Pradesh, in summers also the temperature raises up to 45 degrees centigrade. Similar temperature of 45 degrees centigrade is also there in coastal Gujarat and Mumbai. But this temperature of 45 degrees centigrade in coastal Gujarat and Mumbai will be much more severe to withstand. Why, friends? Because in Uttar Pradesh, for example, you're in Lucknow, the temperature is 45 degrees centigrade. It is very hot out there. You will sweat, and that effect of sweating will give you a slight amount of coolness. But that will not be the case in Mumbai, friends, because what will happen in Mumbai? In Mumbai, friends, when you will sweat now, the air during summers in Mumbai and in other coastal areas, in a generalized way, I'm talking. When you will sweat, obviously the amount of water vapor in the atmospheric air will be very high. So the sweat is not going to evaporate easily there in Mumbai and Gujarat because humidity is high. So because of that increased humidity, the sweat from your body is not going to get evaporated. So you will feel very, very uncomfortable in these cases. And if when the humidity is high, when the air content of your air is very high, when the air content, for example, the water vapor content in the air is very high, so in that case it will become very uncomfortable for you in the heat because your sweat is not going to evaporate easily. But when it is in places like, for example, you can say in where the humidity is less, for example in Uttar Pradesh, in continental areas, so there what will happen, your sweat will go away and you will feel cool. So this is how the sweating process operates. There is one more process, that is artificial process. Artificial process are this, for example, you talk about this AC and heater. In summers, what is happening, friends? You are going to use an AC, air conditioner. So obviously you will get respite from heat. And when winters is there, you are going to use what? You are going to use heater. So this heater is going to give you relief from the cold outside. So these are artificial ways of maintaining your internal environment. So this is homeostasis, friends. You are maintaining your internal environment, be it through natural means or be it through artificial means. Okay, friends. Now there are some more processes associated with this homeostasis. First is we are going to talk about regulate. Okay. Then we'll confirm. Then will come conform, migrate, suspend, ecosystem. First, we are going to talk about regulate. Now, what is happening in regulation, friends? Okay, I've already told you in regulation, internal environment you are going to maintain. So internal environment has to be constant, irrespective of the conditions outside. This is one, you can say, condition of regulate. Now there are many, in addition to the physiological process, there are many behavioral process. So what happens in the behavioral process? In behavioral process, what will happen, friends? That, for example, in a jungle, an animal can go into the shade of a tree, and when it will go into the shade of a tree, obviously it will face less sunlight and it will calm itself. So you can say that this is a behavioral process of saving yourself from excessive heat outside. Then there are two terms involved here, friends. One is thermoregulation, okay, and the other is osmoregulation. Here in regulate, this thermoregulation and osmoregulation is going on to make the internal environment constant. Whereas this osmoregulation and thermoregulation, when we talk about this conformity, in that conformity, obviously the internal environment is not constant, but yes, it helps the organisms to maintain and survive. So what is happening in regulation, this thermoregulation and osmoregulation, they are being deployed in order to maintain the constancy of internal environment. That's it. Now, which organisms? It is important to understand that which organisms are capable of doing this regulation. So we talk about birds. Birds are capable. We talk about mammals. Mammals are capable. Now coming on to mammals, friends. How many types of mammals are there? So friends, there are three types of mammals. One is monotremes. Okay, one is monotremes. I'm writing it here. The next is marsupials. Okay, and the other is placental. Now there is no need to understand that what are these three mammals. Okay, one important fact that you should know about mammals, that mammals are capable in sustaining themselves into very extreme temperatures. For example, a mammal can sustain itself in temperatures like Antarctica. A mammal can sustain itself in temperatures like Sahara Desert. So mammals have excellent sustainable power. So obviously these mammals can very well perform this process of regulation. Okay, so this regulate process of homeostasis is very much, you can say that existent in mammals. Also many birds can also do that. Okay, but there are many people which cannot do this regulate process. Now before coming on to confirm, friends, the process of maintaining the constancy of internal environment in mammals, it is pretty similar to what is going on inside the humans. What is happening in humans, friends? That when it is very hot outside, it is summer, then obviously we are going to sweat profusely. A lot of sweat is coming out of it, which will give us a cooling effect. And when it is winters outside, then we are going to produce a whole lot of heat. Now what is happens, friends, you should have noticed that when it is winters, we eat a whole lot of food. We are capable of eating a lot of food. Now why in winters we can eat more food? Because, friends, outside there is cold. Now in order to counter that cold, we need heat. For that heat, we need more metabolism, or for that more metabolism, we need more food. Because when we will, through metabolic activity, convert that food into heat, and that heat is going to counter the outside cold. So that is why when winters come, friends, the diet of a human being as a general increases. You should have also thought that in winters you consume more, because your body needs more heat in order to counter the external cold environment. So this is regulation, friends, a sort of regulation which is going on. Okay. Then coming on to the next thing, which is confirm. Okay, just focus. Now we are going to talk about this thing, confirm. Now what is happening in confirm, friends? What was happening in regulation? In regulation, the constancy of internal environment was there despite external conditions. In conformity, what we are going to do, friends, that there are many species which cannot maintain a constant internal environment. For example, most of the plants and many animals, almost nearly all plants and many animals, majority of the animals, actually they cannot completely do this thing, regulate. So they confirm. Now what happens in confirm, friends? Their temperature, their body temperature also changes with the change in the temperature of the outside environment. Okay, it's not that outside environment is more and their internal body temperature is constant. Okay, so their conditions are also changing with the changing conditions of the external environments. For example, when we talk about osmotic concentration, this osmoregulation, friends, in this body fluids concentration and the watery content, the salt content, so obviously a sort of delicate balance is required, which helps the osmoregulation process help an organism to survive in, you can say, treacherous conditions, treacherous environmental conditions. So what is happening in this conformity, friends, that these conformers are actually not regulating, they are not maintaining their internal environment, but they are deploying alternate, you can say, methodologies to survive. But yes, their temperature is changing according to the temperature of their environment. This is happening in conform. In regulate, their internal temperature was not changing. Now the point is, one thing that comes to our mind, that with so much amount of evolution over million of years going on, why can't all conforming species regulate? You can see that regulation is quite a convenient process. Internal environment is being constant. So why cannot all species involve themselves to regulate from being conforming? So this is being said that okay, the species are evolving according to the ecological time scale. So why have not all the species evolved, and why have not all the species started regulating? The reason for that is, friends, regulation is quite an expensive task. Regulation is quite a difficult task. For example, if we talk about thermoregulation, really sorry, if we talk about thermoregulation, I'm really sorry, friends. This is my first video with this digital pen and microphone, so that is why it is not. Slowly, I'm going to get practice with it. Previously, I was starting recording with my phone. Now I'm recording with this thing, the tablet. So it will take some time to get acquainted with this thing. So when we talk about thermoregulation, friend, what was happening in thermoregulation, and why that thing is not happening in conformity? When we talk about thermoregulation and osmoregulation, obviously a sort of regulation element is coming in. Now this regulation element is not completely present in conformity. Obviously in conformity, the body fluids are changing their concentration, the body fluids are changing their temperature, but they are actually not regulating themselves. So you should be clear about these two things, friends. This thermoregulation and osmoregulation is going on inside regulate, and very limited amount of thermoregulation and osmoregulation is going on inside conformity, these things. Okay, in conformity, obviously the conditions are changing, the concentrations of the body fluid, the temperature of the body is changing according to the outside conditions. They are not completely regulating. Slight partial regulation is there. So you should keep that in mind. Okay, friends. Now, the question that why have not species evolved to regulate rather than conform? So what happens, friends? For example, I will tell you this one example. For example, there is a example you can take as hummingbird. Okay, hummingbird. It is a very small bird. Now, if you take this hummingbird to Antarctica, say a place like Antarctica, in a place like Antarctica, the temperatures are minus 50 degrees centigrade. Now, what happens in small animals, and by saying this hummingbird, I am trying to portray small animals as a whole. Now, what will happen there when this hummingbird will go to Antarctica? According to the volume of this hummingbird, it is going to have a very large area. With small animals, this is the problem. In accordance with their volume, when compared to their volume, their surface area is quite huge. And when their surface area is huge, obviously, their rate of heat loss and their rate of heat gain will also increase. Because heat loss and heat gain is directly proportional to the surface area of an organism. As simple as that. So when the surface area is large, and obviously if it is this hummingbird, and when I'm saying the surface area is large, it is large compared to the volume of this hummingbird. So obviously the amount of heat lost by this hummingbird in Antarctica will be very huge. So in order to sustain that cold, this hummingbird should produce a whole lot of heat. For that, it should do a lot of metabolic activity. For that, it should eat a lot of food, and this is actually beyond the capacity of this hummingbird. So obviously a hummingbird, when will be taken to Antarctica, it will die, because the metabolic activity of this hummingbird, the metabolic capacity of this hummingbird is limited. So that's why it cannot, you can say, withstands the harsh environment of Antarctica. That is why small animals, they are not capable of sustaining in extreme temperatures, in extremely cold temperatures. For example, in polar areas, they are not able to sustain. So this is one reason that why some species only conform and they cannot regulate, because regulation is a very expensive. For doing regulation under certain circumstances, you need to have a whole lot of energy, you need to have a whole lot of metabolism, and that is not possible for all the species. Okay, friends. So obviously some species are going to regulate, some species are going to conform. Okay, and some species are going to partially regulate and partially conform. So this is the scenario, friends. Okay, now this was regulation and conformity. Okay, in homeostasis. Now next, there are two more things: migrate and suspend. Now when the homeostasis is to be taken place in either a very local type of condition or for a very short period of time. So when the time period is short or the condition is localized, so in that case, friends, if the condition is localized and the period is short, so in that case, you will see two types of methodologies are used. They are migrate and they are suspend. Okay. Now, what is happening in migration? It is very easy, friends. For example, the herders, the mountain herders. For example, when it is summer, so obviously they will live in mountains. When the winters come, they come down from the mountains to the plains, because in the winters in the mountains they will have problem in surviving, and their cattle will also have problems in surviving. So obviously during the winter season they are going to come to the plains. So this is a sort of migration. That is, when the temperatures are extreme in winters in the mountains, they are going to come to the plain region. This is what is happening in the Bharatpur sanctuary, that is in Rajasthan. There is a national park named as Keoladeo National Park. Now, what is happening during winters? A lot of Siberian cranes and other bird species are coming from northern Russia and Siberia to Keoladeo National Park. Why? Because at that point of time in winters, the temperature conditions in Siberia, northern Russia are very harsh. So that is why they need to migrate to come to Keoladeo National Park to get a little bit more, you can say, conducive conditions for their sustainability and survival. So that is why species migrate. And finally comes suspend. Now suspend involves a lot of things. Suspend involves hibernation. Suspend involves diapause. It involves estivation. A whole lot of things are involved in this suspend, friends. Okay. Let's see how it is happening. Now, suspend, the process of learning suspend, it is in two, three things. For example, when we talk about bacteria, fungi, and lower plants, then we will talk about higher plants. Then we will talk about animals, friends. Okay. Now, what is happening in bacteria, fungi, and lower plants? In bacteria, fungi, and lower plants, thick-walled spores are formed. These spores are like these. Now, these thick-walled spores save them from harsh external conditions, and when time comes, they will also help, these spores will also help the organisms to reproduce. Similarly, in large plants and bigger plants, there are seeds. There are vegetative reproductive structures, those vegetative reproductive structures, these seeds also save that particular large plant against temperature, harsh temperatures, and it will also help in, you can say, reproduction process when the temperature conditions become more conducive. So basically these type of structures reduce the metabolic activity of these small and bigger plants. So what is this happening? These thick walled spores, these seeds, they are actually reducing the metabolic activity. What is happening in hibernation? What is happening in estivation? What is happening in diapause? Actually, the metabolic activity is decreasing. For example, what is happening in hibernation? We're going to look at it. In hibernation, what is happening? For example, you should have heard about polar bear, friends. Now, what does polar bear does? Polar bear in winters, it goes into hibernation. That is, it reduces its metabolic activity. It is sort of, you can, sleeping all the time. Sleeping it is. Why it is all the time sleeping? Because, friends, it is saving its energy. It's because if it has to fight the winters, it needs to do a lot of metabolic activity. If it is active, so it becomes inactive, sort of inactive temporarily during winters. That is why it goes into hibernation, which is also known as escape in time. Okay, friends, so you should know, so this is hibernation. Now when the same thing is done by insects, snails, and fishes during summers, it becomes estivation. The same thing when it is done in summers by snails, fishes, and insects, this becomes estivation. Because during this thing, what is happening during estivation, friends? Okay, it is a sort of dormant period of insects, fish, amphibian during summer region. So obviously this winter season it is happening hibernation, in summer season it is happening estivation. And similarly, when we talk about aquatic species, in that zooplanktons many a times go into phase of delayed development, that is known as diapause. Now when we talk about hibernation, diapause, estivation, I'm given a basic idea, friends. If you need to understand these things in complete detail, you have to watch a 1 hour video of these things, because these are big concepts of biology. There are sort of concepts of biology, but yes, when we talk about ecology, we have to slightly connect them to biology also. And finally we'll come to the process of ecosystem, homeostasis in ecosystem. Now how as a whole ecosystem is going to survive? What happens? For example, we are going to talk about an aquatic ecosystem. In aquatic ecosystem, friends, suppose if you know the food chain is something like this. Below there is phytoplankton. Okay. Then when you will go up, there is zooplankton. When you will go up, there is small fishes. Then when we will go up, there are large fishes. And when we will go up, there is whales. So this is a sort of food chain of aquatic ecosystem. Now you say if the phytoplanktons increase a lot. So if the phytoplanktons will increase a lot, the food availability for zooplanktons will increase. So obviously zooplankton will also start increasing. But these zooplanktons will increase up to a limit. Because when the zooplanktons will increase, they will going to consume phytoplanktons. So obviously phytoplanktons will decrease. Now if phytoplanktons will decrease, the food for zooplanktons will also decrease. So zooplanktons will start starving. So the population of zooplanktons will also come down. And when the population of zooplanktons will come down, obviously the population of phytoplanktons will again increase. And this is how the process goes on, repeating and repeating and repeating. An ecosystem is going to maintain its balance. But sometimes it happens, friends, that when you are going to over exploit something, this balance will get permanently disturbed. For example, many of the times this can also happen that obviously if the zooplanktons increase beyond a limit, they will completely finish this phytoplanktons will finish, and then neither the zooplanktons will get food, neither the small fishes will get food. And when small fishes die, large fishes will die. When large fishes die, whales die. So a lot of marine ecosystems, they become dormant because of this thing only. So obviously disturbance to a ecosystem should be limited, and the capacity of doing homeostasis of an ecosystem is also limited. And the biggest source of disturbance for an ecosystem is human beings. So obviously the balancing power, the homeostasis power of any system, of any ecosystem is limited, and it should be not be disturbed beyond a limit. So this was the complete details about homeostasis pen. I'm really sorry. It is the first video in this digital pen mode. So maybe I'm not that much good at in it, but slowly the quality will improve. So thank you for watching this video, friends. If you really like this video, kindly subscribe to my channel. Watch this video again and again. Share this video with your friends. Share it on your YouTube and you can say Facebook profile. That will help me a lot in making more and more these videos. You can ask your doubt in the comment section below, and don't forget to subscribe, friends, if you have not subscribed. So thank you for watching, friends. Have a great day. Goodbye. Take care. Keep studying and have a nice day.